Hello students, welcome to the Python Development Workshop Day 4. I hope I am audible now. Okay, if I am audible then we can start. For today's session, we'll have the classes and objects. We'll have the exceptional handlings for the errors that we encounter while writing a program. And the last topic for the day is file handling. Okay, I'll present my screen. Okay, so coming on to the classes and objects in Python. See, basically your Python is not a object-oriented programming language. That means its base is not object-oriented, but we have the functions and the libraries defined so that we can have the object and classes over also. Coming on to some of the other languages that supports Java is purely an object-oriented programming language. So there's a difference between the structured programming language and the object-oriented programming language. So okay, if I say if I come to the topic of what is basically an object oriented programming, so it is a programming which is based on the objects and classes. Objects are the instances of classes. Classes is basically a blueprint of how a particular object will carry what all things, what all functions that particular object will have to take. So your this object oriented languages encourage your code reuse and modularity. Similarly, like if you want certain objects and certain functions or variables to be a part of various instances, you can have it defined in the class. These class will can be reused, can be created, their object can be created. This way, this encourages your code reusability and modularity. The key principle that is basically of how the object oriented programming languages are working. The key principles are encapsulations, abstraction, inheritance, and polymorphism. So, and what is if you see come on to the class? A class is basically a blueprint of a class is basically a blueprint of how the other objects that will be instance of this class will carry, what all functions they will have, what all variables and the data they will carry. This is basically defined in the class. Now the class is defined using the keyword class. They contains the variables that are known as the attributes. They carry the functions that are known as methods. Suppose if I if I take an example where we have a class named car, the def init is a function which we'll discuss in the later slides. Yes, self, brand, and model are the attributes, and self dot brand is actually pointing to the data brand or the attribute brand. Then we have what is an object. An object is an instance of a class that has the attributes and the methods of a object. Suppose that previously we have created this class car. Okay, now this class car, what we want to make it in use. So what we'll do, we'll basically have the object declared. We will create the object for this class car. Suppose for this time being, we have the object as my car. Okay, So now we just have to provide the two attributes. Like the self is a self attribute. We do not have to provide this. We have to provide the brand attribute and the model attribute. Suppose here we have taken the example of Toyota and Corolla. So here this is a brand and this is a model. Now if you want to if you want to like print the brand, or if you want to print the model, you have to use or want to take an, suppose if you want to take an any brand, any variable to get print, any attribute to get printed, or any function to get printed, or it you want to run that function, you simply have to write object name dot the function name or the attribute name to display the functioning of it. Now we have the init method. This init method is called the automatically when an object is created. So, okay. So when if you declare this explicitly or you do not declare this explicitly, this is going to be if this is going to take place or this is going to be called, this is all automatically called. This is basically used to initialize the object attributes. This is used to initialize the object attribute, the way in which they are called up. Suppose if I say here, this init function is explicitly called here. We call it. If we don't call it also, it will take it. Okay. So if we take an example, I just told you this self is a parameter here. This self dot name is going to point out to the name attribute. This self dot age is going to point out to the age attribute. There is a class which has got the name person, and this has got two attributes, name and age. Now we have got class attributes versus the instance attributes. So class attributes are the attributes that are that is defined inside the class, where your instance attribute is an attribute which is defined for the particular object. So coming on to the class attribute, this is they are shared among all the instances. It means if you define a variable or an attribute inside a class, all the objects that are created inside it will have that attribute. Suppose for an instance attribute, if we talk about, for a particular instance, if created any variable, if you have any variable in use, it is only limited to it, to that particular class. It is not going to be shared among all the instances. Now we have an example of class dog. Suppose we just this is just a way in which I'll tell you the difference between the class attribute and the instance attribute. So if I see here, I have got a class named dog. The species is an attribute here which has got the name canine. We have a function here, init function, which has got the parameter name. The self dot name is going to point out to the name. Now this name is an instance attribute. For a particular instance or for a particular object, whatever name you will give, that name will be printed. But the species value is going to remain same for all the instances. Till this it is clear, students? So this was the basic difference between the class attributes and instance attributes. Now we have looked upon to the class attributes and the instance attribute. Now we'll see the methods in a class. Methods are basically the functions that are defined inside a class. The the first parameter in the instance method is self. I've told you the self is an instance method that is automatically called and is basically used to reflect this data variable that is pointing to the this variable. Suppose if I take this class animal here and I have the init function defined here, then this self dot name is going to point out to this name attribute. Now if I see inheritance in class, whenever we were talking about the classes and objects, we got to know that your object oriented programming basically lies on the key principles that are your encapsulations, abstraction, your inheritance, and polymorphism. So we'll see each of them in detail, but for the time being, let's see the inheritance. Inheritance, if you inherit, uh, suppose if you have a class and you want to inherit some properties of it. So inheritance is a way in which you can inherit some properties from the another class. This basically reduces your redundancy of writing it repeatedly, and it promotes your code reuse. That's way that it means you do not have to define those methods and attributes or those functions again and again. You can simply inherit that class, and those functions, your methods, your attributes will automatically be called up. Then we have an example. Suppose if I have a class parent, okay, then I have a function that has got name show. The show has only one method right now, or one parameter we can say is a self. And I just have this show function which has got the statement to print that this is a parent class. Okay. So whenever I inherit this parent class, I will get the show function automatically inherited into my code. Now coming on to the polymorphism. Polymorphism allows the same functions to work in different ways. That means when you have got a sub function with the same name but their functioning is different. Suppose you have got a name of function for a particular animal, you have got a function name. Suppose sound. If we consider we have a class animal. For that class animal, we have got a function, suppose sound. So for a particular animal that we create under this class animal, we'll got different sounds for the particular animal. So they have got this function sound or this method sound has got the same name, but the functioning or the statements under it have are being changed as per the object that is being created. Now we will see that different classes can have methods with the same name but different implementation. Suppose we have got a class cat here, and we have got a function name speak here. This function name speak will return the sound of a cat. But similarly, if we take another animal and we have got speaks function, this basically going to have the different sound. So this way, we have got a class. Different classes can have methods that have the same name, but they have got a different implementations. Then we have got the encapsulation. Encapsulation basically means that how you can restrict your direct access to the object data. That means only the user will get displayed to the information that is only needed for. No extra information on the insides of the program and the object data will be displayed. Only the things that are restricted to a particular user or to scope will only be delivered to the. Okay, so if I say that how you can declare, we have got some different. Okay, so we have got some private variables and then personal variables and then public variable. We'll see them in the lab after we have done with the slide. When we go to the problem statements, there we'll see. But for the timing, you can always like keep in mind that we use underscores to indicate the private variables. We want to declare that a particular variable is private and its usage is only restricted to that particular scope. We can declare it with the underscores before the variable name. Suppose if I have an example here of a bank account, I have a class with that name pay bank account. I have got an init function here which has got a parameter balance. Now we have got a self dot double underscore balance. This declares that this is a private variable. If you have no brackets, if you have no underscores here, we simply say that this is a public variable. Now we have got abstract classes and interface. So abstract classes are the classes that cannot be instantiated. That means you cannot instantiate. They also used as a blueprint for the other class, but they require the ABC module to be imported. So for whenever you create the abstract classes, you require the ABC module to be imported so that the compiler or wherever in the code text editor you write, you get to know that this is a abstract classes. For that part, for the abstract class, you've got abstract methods only. Suppose I have imported the ABC module and I have a class name animal. Then we'll just have the abstract methods defined under it. We'll see them. Now we have got the summary of what we have studied till here. Is that classes define the blueprint for your objects. Okay. Objects are the instances of classes, and these object-oriented programming basically lies on the principles such as encapsulations, abstraction, inheritance, and polymorphism. This helps in structuring your code efficiently and reusing the components without writing that particular code again and again. Students, do you have any doubt till here? If you got no doubt, then we can move ahead. If you got any doubt, also any doubt from the previous sessions of like tuples, dictionary sets, and list and all. If you've got any trouble with the solutions of the questions or any other problem statements that you're working upon, others also please reply. Then we'll move ahead. Okay, we have no got no doubts. Then we'll move ahead. Okay. So we'll simply write here. Okay, so we'll start. So if we take this example, suppose we'll just start with a simple example as of now. Suppose we have a class name person. Okay. So if I take this example here, and I simply write declare the int function here, and I've got the cell dot name and dot age. Okay. And I cell dot name is equal to name. So this is basically going to give you the name. Okay. Alright, cell dot age is equal to age. Okay. And just simply have this run. So this is it. Now we'll see how you can call this. Now if I have a person, let's say P equal to person, let's have the name, let's say J. It's got the age as let's 34. Okay. And just to print these things, I'll just simply call this. Just to say P dot name, P dot age. Okay. Okay, it is also just like that one. Okay. So we've got the things. Now if we this is just was the very basic. Now we'll see how you can suppose I have a class dog. Okay. Now I have a variable, let's say sound equals to dog. Now I've just got a dog one as the object, and I'll just have the class to be called here. Okay. Okay, then the instance is created. I just simply print dog1 dot sound. Okay, so this way this is called the sound. So here we have got the init function. Now we'll see the init function. Init function. So in Python, class has the init function. This automatically initializes your object attributes when no object is created. Suppose if I have a class, suppose species is a class variable, class attribute, you can say. Now we have init function define here, which is called the self name and age as the parameter. Now if I write self dot name equals to name and self dot age equals to age. Okay, sorry, just got this one. Okay, so if I've got a class name, if I explain in this code, I'll simply say that we have defined a class name dog. Here, a species is a class attribute that will be shared by all the instances of the class dog. The init method will initialize the name and the age attributes when an object is created. Okay, now let's create an object for this. Suppose I have a dog one and I'll simply say dog. Suppose we've got the image of a dog is 2 comma John. Okay, now if I simply print this name and the species, I will write dog one the name and print dog one dot what the what this. Okay, so I simply got the name and the age of a dog one, which was the object of the class dog. Now here, as you can see, dog one, this 4 comma name of the dog. This creates an object for the class named dog, which has got the name as Tommy and the age as 4. Now this dog one dot name will access the instance attribute name. This name is an instance attribute, and this is going to access the attribute of the dog one object. Similarly, for the age attribute, will access this age attribute of the dog one object. Now we will see an example of this on the self parameter. So a self parameter is a reference to the current instance of the class. It allows us to access the attributes and the methods of the object. Now if I have the same class dog here only, I'll have def. Okay, we'll not define the init function, we'll just have the simple function bar defined. So start the self and then we'll just simply run this. Okay, I'll just print the self insert of name. Self of name. Okay, and I'll just have this name. Okay, this is the object created here. Okay, I'll just have the name as same Tommy only and then I'll just have page 4. Okay, I'll simply call dog1 dot bar function here. Since you're saying the dog has takes no arguments. Okay, we'll just try to remove this. Okay, so this probably might say dog takes no arguments. I will simply have this name. Okay. We will start the similar code right here. Okay, I got this sense of it. Okay. I don't know what this is wrong here, but if you see this example here, from here you can understand the what is the use of the self parameter here. Suppose if I have a class, let's see this one. Okay. So if I have this class dog here, and it has got a class variable as species canine. Now if I have the init function defined here, and I say that self.name is the name and self.age is the age. And now if we create an object for this class dog, and I say I pass the 4 as the age and the 4 as the age and the name as the Tommy, and it's going to print. Suppose if I copy this code and I'll try to take up the issue that was there inside that code. It does a copy paste this, okay. And I just have this dev that technique. Just copy self. Simply say print dog1 dot bar. Okay. Yes, yes. Okay, so basically what we saw that the usage of self parameter basically is a reference to the current instance of the class. It allows us to access the attributes and the methods of the object. Here if we say this self.name is referred to the name attribute the object dog1 class. Suppose if I have this dog1, so this dog1 dot bark function is going to calls the bark method on the dog1 object. Now we'll see the str method, how you can convert your object attributes in the str format. Till here, do you have any doubt? What's the issue? Our messages are taking a long time to send. I don't get this query. If you have any doubt area, please let me know. Okay, I guess you guys don't have any doubt, then we'll move ahead. Now we'll see the STR method. So the str method in Python, so the str method in Python basically allows us to define a custom string representation of an object. By default, whenever you print an object or convert it to the string, we use the str method. Now you have a class dog defined here again. I'm taking the same class because you should at least get a basic idea of how each function is working. Now, if I say the init function here, just got the same variable there. Okay. Self dot name equals to name, and then the self dot age is equal to age. Okay, I'll just define this str function again. Okay, just have the self parameter here. Okay, now let's see how you can do this. I'll simply write the return statement here and I'll say f. We'll have this self dot name written under these curly braces. And then we'll have is self dot age, and then simply write years old. Okay. Okay. Now if I say dog1 equals to dog, and just simply say like this. Okay. So if we see this code, we'll simply see that your str. This is defined. This is a method in the dog class that uses the self parameter to get your name and the age printed here. Okay. Now whenever your dog1 is called, whenever your print dog1 will be called, Python automatically uses the str method to print this information. Now if you don't use this str method, you would produce like something that I got earlier here, right? If I don't have this, yes, I can run this. You'll get something like this as found method, found at this, and an address or something would be displayed here. But if I use this str method, here I just call the method and it will work. Suppose if I don't use the str method, then I will get this. Any doubt till here? Others please respond. Pratnesh, I'm taking the Python. If you want for the Django, I would like. This is only for the Python. We have just got that. I just have to cover this Python for the 4 days. For the Django, I have no information, so I cannot say it right now. Yeah, I just want to take like if I'm going very fast or whenever I'm very slow, please try to say so that I'll just have the regular pace maintained. Okay. Because sometimes I like if I'm taking this class in an object to be very slow just because if anybody is new here they would be easily able to catch up the concept. Suppose if you have done Java and C++ before, then you might find it easy, but for the others who have not covered it before, it might be little difficult. Okay, so okay, let's come here back. So, whenever you see any object, whenever you see any language or something, you'll find basically in Python, if we say variables defined in the class can be either of the two types. Either they can be the class variables or they can be the instance variables, right? And they're used for understanding. Now we'll see basically how you can distinguish between them and how their distinguishment is very much crucial for the object-oriented programming. If I come on to the class variables, these are the variables that I told you before that are shared across all the instances of a class. It is defined at the class level. Outside any method, all objects of the class share the same value for that class variable, unless you explicitly like uh, explicitly implement have a new value for that. Now, if I come on to the instance variable, these are the variables that are unique to each instance of the class. That means that are unique for each and every object that you create. And these are defined within the init method or other instance method. And each object maintains its own copy of its instance variables that are independent of the other objects. Now, if I have the same class dog, and I'll just see what is the difference there. I'll just have the species. Okay. So if I simply say that I have a species, this is a class variable. Okay. I will simply comment here. Okay. So this is a class variable. We have the init function, and these both are the instance variables. I'll just comment here. Okay, I'll just run this. Okay, now I'll define the. Now I'll create the objects for them. Suppose I have in the top one. Okay. If I simply have this dog1 as the object 1 and dog2 as the object 2 for the dog class, now these are the objects. Suppose if I run them, okay, class is created, their object is created. Now we'll access the class and the instance variable. Okay, so if I say that I will print, suppose if I say print dog1 dot name, so dog1 dot name is a instance variable here. This is an instance variable denoted with the ID instance variable. Okay, this name is also an instance variable. Suppose if I write hashtag here and if I say dog1 dot species, so species, you as you said, this was the species, the variable, this was the variable or the attributes that were declared outside the init function, and hence this is a class variable, so this is a class variable. Okay, so this define this. Okay, so the name for each dog is different, but the species is same. So species was the class variable, so it was shared in the same day. Now let's see how you can modify the instance variable. Because if I write dog1 name equals to Harry, okay, and just simply print this to see whether the changes are made or not. Okay. So in this way you can modify the instance variable. Simply have to say that what new value you need, it will be printed. Now we'll see the how you can modify the class variables. Dog1 dot species. Okay. Now I simply change the, let's say it's from time. Okay. So the species for only the dog1 is changed, and the species for the dog2 is still the same that was declared earlier. So if we understand this, we'll see that the class variable species was shared by all the instances of the class. When you change the dog species, it does not affect all object. It's only affect for the object that you have changed. Now if you have the instance variables name and age, they define over inside the init functions and they are unique to each instance that you create. For accessing the variables, the class variables can be accessed by the class name dog.species, where the instance variable can be accessed via the object dog1.name or dog2.name. Now, whenever you want to update the variables, you just simply have to write dog1.species is equals to particular word that you want to change, and similarly for the other names and the each you can perform. Is it clear till here? If you have any doubt till here, then tell me, otherwise, just start with encapsulation. Okay, I guess you guys don't have any doubt, then we'll move ahead with encapsulation. Okay, so encapsulation refers to the building of a data or attributes and methods that operates on the data into a single unit, typically a class. Also, it also restricts the direct access to some components, which helps in maintaining the integrity of a code. So, encapsulation is the process of hiding the internal state of an object and requiring all the better knowledge and whatever things you need to the programmer. So, what does encapsulation provides you? Encapsulation provides you better control over data. It prevents the accidental modification of data and it promotes the modular programming. Python achieves this encapsulation using the public attributes, protected attributes, and the private attributes. Now, how this encapsulation basically works? The variables that are kept private, protected, meaning they are only can be accessed or modified through the methods. And methods act as an interface for which external code interact. For an instance, getters and setter are common methods used to retrieve the update, the value, and the of the attributes. Suppose if I say by encapsulating the variables and only allowing their manipulation can only be changed, the others are remaining same. We will see the public members, then we see the private members and the protected members. Okay, that's about that. Before starting with the public, okay, if I have the class name public, so the public members are accessible from anywhere, both inside and outside the class. Okay, information document. Okay, simply write self dot name equals to name. Okay, I'll just have the different function defined here. Tell display name function. Simply say here background details. Okay, I simply print this and I just try it here. Okay, I've created the class and I'll just create the object. Let's say we have an object name as origin. Simply write public. Simply print this origin dot name. Okay, if we understand this code, we'll see that this public attribute name. This attribute is declared without any underscore prefixes. It is accessible from both and from both inside and outside the classes and can be accessible from anywhere. Now this display name is a public method. This method is also accessible from any part of the code. It directly accesses the public attribute and prints its value. This object obj, if this is an instance of a public class that is created, and the display name method is called, demonstrating on how public attributes and the methods can be accessed directly. Here the init function method is a constructor and run as soon as the object of the class is created. Now if we come on to the protected members, okay. Okay, let's see for the protected members then. Okay. If I have a class name protected. So your whole code is same. What I have done here, I've just added the underscore before the mm, name variable, right? This underscore before the name variable tells you that this is a protected member, and protected members are identified with a single underscore. If I run this, okay. So if you understand this code, this underscore name variable, this is prefixed with a single underscore, which by suggests that it should be treated as a protected member. This indicates that it should not be accessed outside of this class. And subclass here is okay. So this way, this tells you that this name variable is a protected member of the class. Okay. If I go for the private member, so the private members are identified with a double underscore and cannot be accessed directly. We will use Maglink to make private members inaccessible by renaming them internally. Okay. So if I have a definite function, self, okay. If I have this variable salary, okay. So this double underscore before the salary displays that this is a private attribute. This salary is accessible through the public method. If you understand this code, you will see the salary attribute which is prefixed with two underscores, which makes you tell that this is a private member and you cannot access them. You cannot access them directly. The salary, this public method, this display salary method provides you the only way to access the private attributes, and this returns the value of your salary. If you try to access the private attributes directly, this will result into the enforcing the encapsulation at a level. You've got a salary. Okay, some problem, but still we see that. Okay, so if we see this, we'll simply find this just the salary is a private number, and it is replaced with two underscores to tell you that it cannot be accessed directly. To access this directly, we have defined a display salary function, which is a public function or a public method, and this displays the salary. Any doubt till here? Students, do you have any doubt? Students, do you have any doubt? Okay. When did assignment week one assignment? I don't understand your doubt. Okay, then we'll start with the exception handling. Do you ever encountered any type of error in your code and you tried to read that error and you would have able to solve out your program? Like the error, you yourself try to debug your program anytime? Okay. Students, have you ever encountered any error inside your code and you read that error, you try to fix that error, and again then your program then your program runs with no errors. This is where you learn how to find the exceptions in your program, how to deal with the errors that we see in our code. So if I simply say, what is exceptional handling? So exception handling is a mechanism to handle the runtime errors. Runtime errors are the errors that we require when we run our program. These exceptional handlings prevents from the program how from the program crashes. Then we've got, it ensures the smooth execution of the code. You can use the try block, except block, findy block, and raise block to raise the keywords. Suppose if I see, so some of the common type of exceptions that we see are zero division error. Whenever you divide your number by zero, it is result into an exception, that is zero division error. That means you cannot divide any number by zero. Then we have the type error. When you use an invalid data type in your operations, it results into a type error. When you have got the name error, this name error will be used whenever you want, whenever you try to use any undefined variable. The variable that you have not defined and try to use it, then it results into a name error. You've got index error. Whenever you try to use the invalid index, you receive this index error. Key error is the error that majorly occurs in dictionaries whenever you try to access the wrong key. Value error is for the invalid argument for a function. Now, if you see how you can get them or try to handle them, the exceptions. Suppose if I have this, without this, we have got a try and the except block. So the try block contains the code that has got the error, and the except part takes up the error for which will display the explanation to a program or to your uh, error that will be there inside the try block. So inside the try block, you've got that x is equal to 10 divided by 0. This 10 divided by 0 contains a zero division error. So here for this in the except clause we have got an error defined as zero division error. This zero division error has got the statement print cannot divide by 0. So if I run this code here, we say try 10 divided by 0. Okay, if I run this. So this will say that you cannot divide a number with 0 and this will result this except plot statement zero division error is printed. Now, if I see how you can handle the multiple exceptions, you can catch the multiple exceptions in a single block. Suppose here we have the try block, which has got convenient. Here we are trying to convert our string ABC into an integer or into a num variable known as. So this will automatically result into a value error and the type error. So for this we have defined that it is an invalid input. Suppose if we try to run this, if I have a try block here, num is equal to int, simply write and I will tap this. Okay, I just have the except block here. Okay, so this is a value error. I'll simply write here what we were written in our slides. Invalid input. So we have got this exception. This is how you can handle the multiple exceptions. Just enclose this in the parentheses. Like I'll just write this. So it's saying it is invalid input error. Now, if you see how you can use the else block, so this else block will be executed only when there is no exception called. So let's try to use this. If I simply say try equals to, sorry, try, I just have this num is equal to int 3.14. Okay, we just have except. Okay, we'll just have the else block. Simply have the no error encountered. Simply. So it says that there is no error occurred. Now, if we go again, we'll see the finally block. This finally block will always execute, and basically it is used for cleaning up the operations that we have performed above. Okay. For example, if I take this try block and I open this file and I have this exceptional that this file is not found, I'll print that file is not found. This finally block will just have this all the operations closed. That means all the tabs that were opened to search for the files will be closed and the memory will be cleaned up. Suppose if I do this, okay, 10 divided by 0. Okay. So in this way, you'll see that this finally block will always execute excellence. Okay, so it says that this is zero division error and this finally block will always execute. Suppose if I just replace the 0 with 2, then also the same thing. This finally block will always execute. This finally block is also used to clean up the operations and the data that was stored for the memory. Now we have got how you can raise the custom exceptions. So, whenever you want to raise the custom exceptions or you want to have the exceptions that you want according to your type, okay, according to your perspective or whatever your code is necessity is. So, here if I take an example of how you can check the age. So, if I have the check age function, this check age function contains the age parameter, and this says that if age is less than 18, your age must be equal to 18 should be printed. Else you should else you should always have the return statement that says that access is granted. Now we have the defining custom exception classes. You can define your own custom exception classes. Okay, so I have a class here. Let's say class custom error, and this is an exception. Contains some exception. And if I simply say that there is an init function defined, I'll have the self as the method here, and message is a parameter. Self.message is equals to message is a self reference parameter there. Then this is how you can actually raise your custom exception classes, or you can have your own custom exception classes defined. Okay. Now we'll see some of the best practices that are needed for the exception handling. Okay. So if I say that this is how you can handle the exceptions. So handle only necessary exceptions. That means you should not handle any other exception. Only that are required should be handled. Then we've got we should use the specific exception types instead of the general ones. Okay. So whenever we say that for a particular exception, you should have a customized exception defined. You should not have the general exception. Okay. And then we'll have the you should keep your error message as informative as you can so that it displays the proper explanation to the error. And then we have you should avoid using pass in the except block because if whenever if you use the except use the pass statement, it is not going to give you the proper definition of your errors. Now we'll see the summary of the exception and handling. That is exceptional help in error handling and the program stability. They define you how better you can handle the errors and manage your program. Always try to use try except block to catch the errors. So you can always have your code defined inside the try block and the errors and the resulted errors or something inside the except block. So whenever you find that there is an error, you could easily catch up. Okay. We'll have the else block run whenever there will be no exception occurring. Okay, so as we saw here, this does not got any error. So whenever we try to see, whenever there is no exception occurring, your else block will run. Final block will always execute no matter if there is an error thrown or not. Okay. Custom exceptions can be created for the specific needs as per the user's necessity. Okay. Any doubt till here with exception handling? Okay, so if you have no doubt, then we'll move ahead with the file handling. Okay, this is the last topic for the session. Okay, so if I see what is file handling, we'll see that file handling allows the Python programmers to read, write, and manipulate your files. They are used for storing and retrieving your data. They also support different data types that they could be your binary files, they could be your text files, they could be your CSV files, or something like that. We use the open function to interact with the files. We first open them and then we see that we want to write something on the file, we want to read something from the file. This so if you come on to the fact that how you can open a file. So the syntax to open a file is you just got the file. This is a variable that will hold or that will carry all your information whenever this file will open. Now we have the open keyword here to open the file. We have the file name and the mode. So the mode can be read mode, write mode, append mode. Okay, binary mode and the plus mode to whether to say read and write. Okay, so if I say so if I say that R. If in mode I write R, it is only going to read it. You cannot edit it. If I'm going to write W, you're going to say that it will override the existing content. If anything there is there and you want to add to the file, you will always open in the append mode. Then we have got the B mode, which says that you can have the binary mode, that is write binary or the read binary. Now we have the plus to see read and write options. Okay. Okay. So if we say that how you can read from a file. Suppose if I say read, this will read your entire content. If I say these are methods for reading a file, and if I say read line, this read line reads your one line at a time. This read lines will read all your lines that are into a list. For example, if I say file with open, if I say open and I simply say data.txt, this data.txt is a file. Okay, data is the name of the file, and R is the reading mode. Like open this in the reading mode. I'll just want to read the file. Whenever you want to just read the file, you'll just have it in the read mode. Then I have content is equal to file dot read. This content is equal to file dot read will hold up all the content of your file. If I say print, this will print the content that was there inside the file. Do you have any doubt till here? If you have got no doubt, then can you tell me if you want to open a file? Like just tell me the code, or you can write in the comment section. If you want to open the file in the read mode with, and the data and the file name is suppose file one, and in the reading mode, or you want to open this in the write mode. Write mode, that means you want to add overwrite to the existing data. How you can write it or how you can do it. Okay, so okay, yes, you will use the append mode to write to the file. Yeah, that was correct. Okay, so we'll see how you can write to a file. So whenever you want to write to a file, use the W mode and with the A to append the content to the file. Suppose if you have got a file and we'll open this and we'll simply have the mode W to write to a file. Suppose if I want to write anything to a file, I'll simply write file. This file is the variable that will hold all the necessity details of the file. So this will I simply call the write function file.write and all the details in the string and the list that you want to provide to write will be stored here. Now I'll have file.close to close the file. File.close is always necessary to please to clean up the memory that was taken up by the compiler to arrange all these things. Now we have the with statement. The with statement automatically closes the file. You do not have to write file.close function. This with is automatically going to close the file. So if I write with open data.txt in the read mode as the file, it will read all the content and will store in the content, and this file will be closed without writing the file.close function. Now we'll see how you can work with the binary files. Binary files are the files that store the data as the raw bytes. They are either in the write binary or the read binary modes. For example, if I open image.jpg, this is the image. In the write read binary as file, we'll simply say that whatever the things that you have read here, store it in the variable data in the form of list. Now, if I copy this, this is a read binary. If we want to write anything to a file, we'll simply write. If I copy this data, and I simply say that write this, I now copy the new image in the write binary mode. Now I just use the write function to paste the data that I've copied from here to the same image. Now these two images will carry the same data. Now we have got some file handling methods. So some of the file handling methods are file.readn will read your n characters. File.readline will read only reads one line. File.readlines will read all the lines into a list. File.write text will write text to a file. File.seek_offset will move the cursor to a specific position. Then we've got file.tell functions. This returns the current position of the cursor, where your current cursor is pointing to. Now we've got how you can delete a file. To simply delete a file, you use the OS module. You first import the OS module, then we write os.remove the name of the file that you want to delete. Now we have got the handling file exceptions. How you can handle the file exception. Before starting with the file exceptions, let me know if there is any doubt till here. Okay, if you have got no doubt, then we'll move ahead. Okay, so now we'll see how you can handle the exceptions that occur during the file opening or whenever you want to read the file or something. So the very first thing that we encounter is while with the handling is that your compiler is not able to find the file. If they are not able to find the file, then there will be an error. So this error can be like we can handle this using the fact that we use the try, we use this open and this content portion inside the try block that will actually see whether your file is there or not. Then I'll keep the exceptions in the except block and I'll say that except file not found error is the error and I'll just print that file is not found. Now if I come to the summary of the file handling, then Python allows reading and writing the files easily, right? You can use the open method with proper modes, read binary, write binary to work with the file handling. We should use we should always try to use file.close function or with the statements to actually practice a good file handling. And you should always try to handle the exceptions that occur while reading the file, while writing the file, when you're opening the file gracefully. So this was about the file handling, the exception handling, and the classes and objects that we encountered. Basically, in the last few four sessions, we tried to cover up the Python as much as possible. For any errors, for any sorry errors, this has been like moving around in my head. For any type of doubt or something, you can always come. So this was all about today. Thank you for the 4 days session coming in. I hope you have taken a good knowledge of the programming. Have a good day.